Hey everyone, so in this video we'll talk about the control flow statements that fall in the choice category. And just to recap, we call it choice because these statements pick between one of the possible paths forward when there are more than one. And the more formally, these are called conditional branching statements because branching is because the control flow splits into multiple paths. So the execution comes as the sequence of instructions comes, and then at some point there are multiple ways forward. So this is called branching. And why conditional? Because we pick the one of these paths, or not we, the program picks one of these paths forward based on some condition, evaluating the condition, and based on the result of the evaluation, picking the path forward, which is a code path, as we already learned in the previous video. So another thing I want to just recap, this is a little important for this video, is the labels and goto. So remember that label is basically a tag we assign to a line of code or to a statement, and then from anywhere in the code we can say go to that label or go to the line or the statement with that label. So here I have a small example showing how it's written in a common programming language. It would be, let's say we have a variable x, and we assign it zero to it initially, and we have this, the second line is actually incrementing the value of x by 1, but we have a label my line added to that line. So the next line just outputs the value of x, and then the last line is the most interesting, which says go to my line. So what this will do, it will increment the value of x initially, so it will be 1, and then it will output 1, and then go to my line, and it will increment it again, output again, go to my line, and infinitely repeat this. So it will start outputting all the numbers, integers starting from 1 to infinity until we terminate the program. So practically this program is not useful, but this is to illustrate how the goto works with label. Okay, so now back to the control flow statements. Again, goto is also one of them, but in this video we are focusing on the choice, which are the if and then the switch or case. So let's start with the if. It's a little simpler. So if is the most basic control flow statement that allows us pick between two paths and based on a condition. So the minimal form of if statement, when we write, we provide a condition. We say if some condition, then do something. So the keyword then is skipped in some programming languages. The syntax is different across languages, but usually it's always if and then condition, and then optionally then, and then the statements to execute if the condition applies. So if the evaluated result value of the condition is true at runtime, and then there might be some ending keyword in some languages, so it can be end if, right? Or if we use blocks, we know that some languages will just have these curly brackets containing all the statements that needed to that will be executed if this condition applies. So that's the most primitive form, and the practical example is again our orange juice problem, right? So we can write if juice.flavor equals orange, then increment count. So that would be a good use of this if statement. So another, a little more advanced or extensive form of if is the if else statement. So instead of just saying if this condition is true, do something, we can say do something if this condition is true, otherwise do something else. So the syntax is similar, except that we add this new keyword else. And it's like if, and then condition, then statements or statement, and then else, another set of statements, and then again optionally this terminating keyword, which can be and if or something else. And then there is even more advanced form. So if we have more than 2 paths forward, we can say if this condition applies, then do this or these statements. We can say else if. So else if is actually a single keyword. Sometimes it's written together. In some languages it's separate, but it's a single keyword. So you say else if, and you can provide another condition, and then you can have that multiple times, and then at the very end you can have else, and then the terminating keyword. So if then else will allow us to pick, as I said, between 2 branches, 2 possible choices. So let's say we want to count number of, we know there is a bag full of balls which are either red or blue, so we need to count the red balls and count the blue balls. So we would have, every time we pick a ball, we would say if the color is blue, then add the current number of blue balls, else add the red ball. So we know that there's no other color, so we know that for sure if it's not blue, then it's red. There's no other option. That's why we can use if, then else. So in case there are multiple, so let's say if the bag has also green balls, then we could use this if, else if, and then else. So we can say if color is red, then red count plus plus. Else if color is blue, then blue count plus plus. And then finally else, now we know that the only remaining choice is, which two I said, red, blue, green. Okay, I think so. If it's none of the 2, then it's the third one. So we can do whatever. And again, we can repeat this else if as many times as we want, and which means we have the more basically branches, potential paths forward we have, the more else if conditions we can add. So apparently, yeah, the next else, every other else happens only if all the previous conditions were not met. So this is how if else or if else statement works. And you see it's a conditional branching, so you basically pick, the code picks a way forward or the code path based on the condition we provide to this if statement. So I think that pretty much covers what the if does. And again, different languages have a little bit different syntax, but I think the keyword if is there always. And the conditions, we know some of the operators we can use for relational operators. For instance, you can say if a is less than 5 or if a equals 6, but we'll get to more conditions. Basically any type of expression that any expression that has a Boolean type or that evaluates to a Boolean type can be used as a condition. So that's I think enough about if. So let's go to the next control flow statement, which is the switch. So in some languages it's called switch, in some languages it's called case, but the functionality is the same, and what it does is pick a code path or a branch from n different branches based on the expression, evaluated expression, or a condition. It's actually a condition always, but the syntax is different. Sometimes we evaluate the expression and then we give different conditions for each code path forward, or sometimes we evaluate the condition and then give different values for the code path forward. So here I listed different syntaxes from different programming languages, just to give you an idea like how how different the code can look in different languages, but in essence they are all doing the same thing. So the first example is common, let's say, I think in Java, in C#, C++, you can have this. So you provide the expression so you write the switch keyword, and then in parentheses you provide the expression which needs to be evaluated and checked against a predefined set of values. So you can say, and then you have cases, right? Each case keyword defines determines or defines a code path or a branch that the control flow might follow. And if your expression basically has this value, this given value, it will pick that case and continue from there. So it will execute all the statements under that case. And note this break keyword. It's a keyword. It's not something I made up, and it is used to terminate this case, because if we don't terminate, so let's say if we have juice.flavor in an expression, and we have case orange, right? And then we also have case apple. So in case orange, we want to increment the number of orange boxes, and then in case of apple, we want to increment the number of apple juice boxes. So if we don't break after incrementing the orange juice boxes, the code will continue through all the other cases. So it will increment also apple, but that we don't want to do. That's why we need to break. Basically, the case defines the starting point. It's similar to the label. So it's similar to saying, if the value is value 1, or in this case orange, go to this label. And label is implicitly we understand it as the line that contains the statement 1. And which means after that it will execute all the lines one by one. So if we want to do only this set and then not the ones that are for case 2, we have to say break. Okay, so another example, I don't know which language I picked this from, which programming language, but this is another form of writing it. And as you see, this example is using the case keyword, not switch, but in essence it's the same. So it's again case, expression, and then off, and then instead of cases we have when. So we say when condition 1 applies to this expression, then basically the result of this statement is value 1. And then when condition 2 value 2, and then else is similar to the default. So when none of the conditions or none of the values matches the expression value, it goes to the default. It falls back to the default case, or in this case it's else. And the third example I have is also using the case expression, case keyword, but this is a little bit different, because now instead of conditions, when we have values, so it's checking against specific values instead of checking if the condition applies to this expression. And also instead of else, we have this when others. So just putting this 3 different syntaxes, I just wanted to emphasize that it can be completely different keywords. It might look completely different, but when you read the code, wherever it's written or whichever form it's written in, you will understand that this is the switch or case statement, and all it does is pick one of the branches or pick one of the paths forward based on an expression or based on a condition or the value of expression. So again, this break is very important, and in both cases, for if and switch, whenever we want to have one statement, we can just write it down. If we want to have more than one, we should wrap it in a block. So it will either be some opening tag, closing tag, or some sort of brackets, or a special keyword for a language like end if, or end switch, or end, as you see in these case examples. So this covers the choice control flow statements, and we can basically now do a lot more things than we could before this. So I think we could now solve all the 3 example problems that we talked about before. But before doing that, let's jump into loops now and do another video about those, and then we can go back to the problem, see what's the most optimal way to solve them. Thank you. See you in the next one. Bye.